This presentation is on test coverage to determine test adequacy by Christopher Lujo and James Harris. When testing, it is impractical to test every possible combination of inputs and interactions that occur within a program. Therefore, we need to decide when enough testing has been done to give an accurate measure of the quality of the program. For this, we need to define what our adequacy criterion will be. That is, we must decide whether sufficient testing has been done that the testing can be stopped. One of the things we need to look at when making this determination is test coverage. That is, how much of the program was covered by the testing. An adequacy criterion is an essential part of any testing method. It plays two fundamental roles. First, an adequacy criterion specifies a particular software testing requirement, and hence determines test cases to satisfy the requirement. A very basic requirement of adequate testing is that all statements in the program are covered by the test execution. Test coverage is always measured in a percentage. There are a number of metrics that can be used when calculating test coverage. We can look at the percentage of a program's subroutines or functions that were run. We can look at percentage of program statements that were run. We can look at the percent of edges that were covered in the testing. That is, many subroutines interact with other subroutines. We can measure what percent of those possible interactions were tested. We can also find the percentage of branch coverage. That is, we can measure what percentage of possible conditions that were tested for each conditional statement. We can also look at the percentage of condition coverage. That is, the percentage of Boolean expressions that were tested in both their true and false states.
With test coverage, there are some upsides and some downsides that could be seen when using this particular method. Some of those upsides we actually have listed here on this slide, starting with how test coverage helps create a thorough set of tests, since it provides a sort of template to run and create the exact points that need to be run to make this test successful. Which carries us to the next point, that it provides a sort of measurement or metric that can be used to test the quality of the source code. Another point is that it allows the tester to create a clear checklist test complete. It provides a template, like I mentioned previously, to create the points and corners in your own perspective to have an accurate and fully functional test, and therefore a complete source code. It allows and provides the ability to identify defects and faults in the code in an early step of the overall programming, since it can be found and noted throughout the test coverage. It also provides a deep view and reveals important aspects of software engineering for learning and testing purposes. All of these upsides that I've mentioned that come along with testing coverage allow for the final point to be made clear, that it indirectly helps the quality of the code and the overall product to not only be better, but a higher amount of testing possibilities. The downsides to doing a test coverage and test adequacy are listed on this slide. One of the major downsides to having test coverage and test adequacy, even method for testing, is that only metrics that are written in test coverage, the ones that are covered, the ones that are mentioned, are those that are tested against. Thus, missing some points that haven't been defined or might have been forgotten in the test coverage since the beginning. Another point is that it takes additional and extra effort to make sure that the test coverage is thorough and complete. If the effort is not placed, and therefore the effort is not 100% there, then the test coverage will not be complete and will not be thorough enough, an adequate testing method. And lastly, that the connection between structure-based measurements and their reliability is not understood. This quote is actually spoken by Marko Ivankovic, who is actually a software engineer for Google. The quote actually mentions a little bit about the downsides and the upsides that go along with test coverage. The quote reads, "Some people think it is an extremely useful metric, and that a certain percentage of coverage should be enforced on all code. Some think it is a useful tool to identify areas that need more testing, but don't necessarily trust that covered code is truly well tested. Others yet think that measuring is actually harmful because it provides a false sense of security." This actually carries on with the previous slide where we talked about the downsides. That if the test coverage isn't fully thought out and the effort is placed, then test coverage will not be completely effective. It will not completely reflect all the metrics that need to be done for the source code to be complete and fully secure. Now, I'm going to emphasis on a few, starting with Google, then Facebook, on their approach to coverage department. Google actually defines their coverage department as two different categories. One is daily coverage, in that they test the work in progress code on the current day, the actual day when it's run, which allows and helps their engineers fix errors before they get too far along in the code or in the projects with those errors persisting. Another point that Google wants to emphasize is per commitment. We focus down on only the tests that need to be done in order to allow for the commitments to run smoothly. This is actually that we could apply into our own code and into our own software engineer lives, that we should be running those daily coverage codes and daily coverage tests to make sure that the errors that are persisting in our code are eliminated and therefore won't be persisting in the future. And this is talking about Facebook itself, and this is Facebook's approach to coverage department. They actually use two forms of methods, and they try to keep it as simple as possible. Complicated. The first one is PHP unit, which allows for unit tests to be run on their PHP program and their PHP source code. And then Waltier, which is actually a testing tool that runs both human interaction and machine simulation to see how that content for the end user, allowing us to have a fully functional and fully tested out Facebook source code.